All right. Well, hi, everyone. I am so excited to be speaking to you today at Chaos Engineering Day. So thank you to GOTO for having me. It's an honor to be here with so many other voices in the chaos community. Today, I'm going to be talking about how the application of chaos engineering to the security domain can tangibly move the security needle at any organization. So a little bit about me. As Casey said, my name is Jamie Dicken, and I am the manager of applied security at Cardinal Health. So I am responsible for leading a team that's focused on the security validation of our controls. I did recently contribute to the O'Reilly report that Kelly and Aaron have put together. So if you're intrigued by this talk today, I will make sure to share the link again so that you can grab it for yourself. And prior to my role in security, I did spend 10 years of my career in software development. So I do have a lot of experience in building and designing systems. So it's this combination of being a builder and a security professional that helps really make security chaos engineering just make so much sense. I have a quick but exciting talk lined up today. So first, I'm going to discuss the reality that we face with so many of our security programs and how they're really based oftentimes in assumptions and theories and not evidence. Then I'm going to talk about how the application of chaos engineering can solve this problem in the security space and how I went about doing that at Cardinal Health. And then finally, I'm going to wrap up with how you can also get started to drive real security outcomes at your organizations too. For many of us, it's sad, but it's true. We don't know our security controls as well as we think we do. We might start off and we know what our original intentions and designs are, but things change. Either projects run out of budget or time before our plans are executed. Our documentation can be wrong or outdated, and that thwarts even our best threat modeling attempts. And mistakes, accidents, and misconfigurations happen. Not only do they happen, but they continue to happen at alarming rates. Year over year, for the past decade, we see this cost of a data breach report come out, and it remains unchanged. We continue to hover at this 48-49% of data breaches ultimately caused by the failure of our controls or our processes. So we really have to ask ourselves, why does this happen? Unfortunately, as more time goes on, the reality is that our perception of our security posture becomes based in narratives and assumptions and beliefs. We end up trending in the wrong direction. We go from reality to theory, which isn't good for any of us. And I wanted to give an example to paint this picture. So here, we know what our plans are from the start. We plan to implement firewall rule standards in the cloud. So we form a belief about what our future security posture is going to look like based on those designs and those high-level plans. And what really happens is we start to form this mental model that becomes pretty unshakable. It becomes so unshakable that even when concessions are made and scope is just flat out cut from the project, our perception of our security posture doesn't change. But what's worse is that even when our controls are weakened over time, and in this case, they weaken twice. First, this team failed to revert a misconfiguration, and next there was an organizational lapse. But at this point, now your beliefs are just downright wrong. And at this point, when you start to consider what your security posture is, you're completely separated from reality. What's ultimately missing from this picture here is just evidence and a feedback loop that would actually inform and update that mental model of how you see your security posture. And this deviation from reality and what we just saw, it leads to really bad security outcomes for our companies. Based on incorrect assumptions, we can miss opportunities for protections, or we make really bad strategic decisions and decide to focus our efforts elsewhere while we leave a big gaping hole behind us. And so really, in order to avoid that inevitable fate that happens when you assume, this is where we find the tried and true methods of chaos engineering to be the solution. It's just that instead of injecting turbulent conditions in your system to see how it responds for the sake of learning about its resiliency, you're trying to learn about your security posture. By performing experiments, you have the ability to collect evidence and data about how your security controls actually perform or how they're actually configured. And it's really by observing them in the wild where you can start to add more recent data to your mental model instead of relying on either outdated truths or worse, even things that weren't true to begin with. And this is powerful because this is really what helps you turn that needle and turn your security back from theory to reality. So, this is usually the point in the conversations that I have with people where they'll say, and we saw this today in the Slack channel, this all sounds great, but my company's never going to go for something like this. We're really risk averse. We don't want to impact production, and we don't have the maturity or the culture in place to be able to experiment. And you know what? Like Courtney was saying earlier, most companies are like this. There aren't a lot of companies that are going to say, it's fine, just go wreak havoc in production. And, if something breaks, at least we've learned something. I can only imagine what it would look like if you sat in on an RCA or a postmortem meeting. You have some executive ask, why did we have that super costly outage that took us down for hours? And for somebody to have to raise their hand and say, we did it on purpose, but we learned something, that's not really acceptable in a lot of organizations. Uptime SLAs aren't just made for fun or bragging rights. Our companies are in business to meet our customer needs, and to do that, they need our systems to be up. The good news, though, is that you can still conduct experiments that don't involve breaking your production applications. As Aaron was speaking today earlier, he said, some of the primary use cases for security chaos engineering include security control validation, incident response, and observability. And the good news is that you can create low-risk ways to test for some of these things without impacting your production applications. And as so many of other speakers have acknowledged, especially doing this in a lower environment before you test prod is going to be to your advantage. As a couple of examples, say you have a control that watches for public storage buckets and closes them automatically. Just go ahead and conduct this experiment. Create that public bucket and see what happens. You'll be able to learn, does it actually get closed the way that you think it should? Does the timeline where it gets closed, does that meet what you expected based on the documentation? Similarly, if you have detections in place for rogue access points, what happens if you connect one to the network? Now, obviously one that you own and that is, is safe, but does it get detected? Is there enough information available in the logs where a human can see it and respond to it? To go even further, if you have a playbook of what happens when an unapproved firewall rule is open, or when any protective system stops being configured to protect your environment, go ahead and do it, but carefully, obviously in a low risk environment to start especially, and make sure to remove it when you're done. But test again to see, do you see it in your logs? Does an alert actually fire? And is somebody actually responding to that alert? Those are all security chaos experiments. The greatest world-class security chaos teams, they started small at 1.2. And what's really cool is that even if you're just starting out and you feel like even these experiments are too advanced, you can start to do something even lower impact. Just start to query some of your security configurations. So many of our security tools today have APIs that you can write just a couple lines of a Python script and check them out. For example, if you know that you're supposed to have a security agent installed on every employee's laptop, is it actually on every employee's laptop? Is it on the current version or at least N-1? Is it running in the first place? The cool thing is that these are experiments that they don't even impact any of your environments. You're just taking a look to see what's out there. And so based on what we hear a lot from world-class chaos engineering groups, I know there can be some cognitive dissonance usually at this time. There have been people who have come up to me and said, what you've described doesn't seem to be snazzy enough to be security chaos engineering. And first, trust me, like I said, no world-class chaos engineering group started where they're at today. But I also wanted to take this opportunity to highlight that this is another myth of security chaos engineering, that there's some kind of threshold for how exciting your experiment has to be for it to be considered real security chaos engineering. If you think about it, chaos engineering is called that because you are carefully and methodically instrumenting chaos. You are not just carelessly wreaking havoc in production. Security chaos engineering is executed practically like any good scientific experiment because, like we said earlier, that's pretty much what it is. You first form a hypothesis of what you believe to be true. You execute a set of prescribed steps to either prove or disprove that hypothesis. And then you take a look at what actually happened so you can learn from it. And I know that by distilling it down in this way, it can seem less exciting or less glamorous. But for those of you who think that your company just can't or won't implement security chaos engineering, distilling it down in this way makes it something that, in discussing it in this way, makes it something that it's possible for your organization to choose to adopt it. And if we think about it, testing our systems really isn't a novel concept. Software developers do this all the time. They write automated unit tests to make sure that new code doesn't break old code. They perform regression tests in lower environments to make sure that upon their go live, they're not going to cause major impacts. And even once those deployments happen, there are people who are testing and performing smoke tests in production to make sure that they didn't break anything. And like I said, those smoke tests happen in production. And this is a widely accepted practice. And there's no reason that security chaos engineering can't be either. The key and why that practice became so widely accepted is that smoke testing is performed in a controlled and a disciplined manner. And that's really how we should be treating security chaos engineering as well. I did want to give an example of how we implemented this at Cardinal Health. So Cardinal Health, if you haven't heard of it, is a Fortune 20 healthcare company based here in the US. Not only are we a major healthcare company, but we're in the middle of a pandemic. And I say that because I want to assure you that we do not have a cavalier attitude when it comes to our production systems. In fact, it's because we don't have a cavalier attitude that caused us to invest in security chaos engineering in the first place. 2 years ago, our leadership acknowledged that we believe that the tools and the patterns and the standards and the designs that we have keep us secure, but we realized that that was just an assumption. The reality is that the ultimate effectiveness of our security controls and our processes, they really rely on other people carefully and flawlessly implementing them. Even the best made security solutions can be rendered just totally useless if they aren't configured correctly or if somebody makes a mistake. And going back to that cost of a data breach report, we see that for a decade, we have had mistakes and misconfigurations, and we aren't getting better as an industry. What Cardinal Health did is we created a brand new team, the one that I lead, called Applied Security. Right now, we are a small 5-person team, and among us, we have expertise in software development, security architecture, systems administration, security operations, privacy, network security, and cloud. And our mission is to proactively experiment with and validate our security controls so that we can identify those gaps or misconfigurations or mistakes and drive those to remediation before an adversary finds or exploits them. When we got started, we had to create a disciplined and a repeatable process that wouldn't disrupt our business operations. What we came up with was we called continuous verification and validation, and it's a pretty straightforward, simple process. First, we pick the control that we want to evaluate. And next, we define what standards or what benchmarks we need to evaluate that control. Typically, we like to use what our security architecture team comes up with because those are publicized widely and they are approved by our CISO. So that gives us some credibility that if we find gaps, the expectation is already there that they need to be fixed. Third is really where the fun happens, and that's where we create our experiments and we build the automation to validate our security controls. Once we build this automation, we run it on a continuous basis, whatever makes sense for that control. But it's multiple times a day. Next, we create a dashboard that shows our real-time adherence to the benchmarks that we've set. And this forms that foundation that we can have data to make decisions about our security posture. And then finally, if our adherence to any of our benchmarks suffers, then we fire off an alert so that we can proactively take a look at it and we enter something into our security issues log. The beauty is that once we got this process in place, our beliefs about our security posture became based in evidence and data and not our outdated beliefs or our assumptions. I like to share this use case because, as you see, security chaos engineering, it's not just for the ultra glamorous high-tech companies of the world. If your methods are sound and you carefully plan and execute, security chaos engineering can really be for anyone, regardless of what industry you're in, how mature you are, or what your culture is like, what regulatory requirements you face, and whatnot. The key, again, is to really instrument chaos, not inflict chaos on your company. So hopefully that clears the air a little bit and starts to get everyone excited to really validate their own security posture. The good news is that once you're there, getting started is easy. Even if you haven't gotten the investment to build a team that's focused on security control validation, there are still plenty of ways that you can get started on your own without that investment. First, as many people have been saying today, there is a brand new free O'Reilly report on this exact topic. It was written by Kelly and Aaron, both of whom spoke earlier today. And it features not only a lot more detail about my Cardinal Health story, but the stories of other companies across the world, including Capital One, CloudStrike, and others. If you go to verica.io/SCE-book, you can download it for free. So I highly recommend that you do that. Next, once you've read and understand the basics, now you get to do some thinking about what are some simple, small, controllable, and low impact experiments that you can execute right now. Again, the key is to really start small and learn, not go straight to let's kill a container in prod and see what happens. What you'll be able to do is learn about what your controls actually look like and how they're actually configured. And hopefully, even by doing just some small experiments, you're going to be able to prove value right off the bat. And if nothing else, even get some confidence in the process so that you can get continued investment and access to be able to do more. Before I go, though, I do want to leave you with this. We do security chaos engineering for a reason. It's not just to be a part of the latest and greatest. It's not just a fad. It is about learning and getting evidence, but ultimately those learnings are meaningless if they don't drive change. If you think about how almost any security gap gets remediated, we start off by thinking that we're safe and we're covered until somebody asks a question or something makes us wonder. Then we perform experiments and get the data to understand what our reality is. But it doesn't stop there, and it can't stop there. Once we've done that analysis, this is really where the magic happens. It's because of our experimentation where we're equipped with data to have the right conversations to fix security gaps. And this is how security moves from being theoretical to practical. Our security posture becomes what we thought it was, but this time we're right. And if we've done our jobs well, we have that tooling in place to make sure that it stays that way. So security chaos engineering, it really gives us that evidence-based confidence in our security posture. And when we know what our reality is, we can better protect our companies, our systems, and our data. So again, I just want to thank everybody for attending and to the organizers of GOTO for having me. Hopefully you found this valuable. I've listed my contact information here if you want to continue the conversation. And again, please download the report. There's lots of good stuff there.